Here is problem 4, applying multiplication of binomials. Here we have a real-life situation, a cylinder, that has the dimensions shown in the diagram. Which polynomial in standard form best describes the total surface area of the cylinder? Note one thing that makes this a problem of multiplying binomials are that the dimensions of the cylinder are given to us as binomials. So note the radius of x plus 1 and the height of x plus 4. Now, in the recommendation as to what to think for this problem, it says, how can you simplify x plus 1 squared? Well, write the expression as x plus 1 times itself, x plus 1, and use some of these new skills you've acquired for multiplying binomials. Do not distribute the exponent. Be careful of that. That's a very common mistake students make, is to distribute the exponent to both terms when in fact that's incorrect. Multiply using the FOIL method or one of the other methods that we've discussed, but FOIL will most likely become your preferred method for a variety of reasons. So let's continue this problem. Our answer choices are A, B, C, and D. I won't read them. We'll check in on those in a moment. But each of those trinomials could possibly represent the surface area of our cylinder. So the total surface area of a cylinder is given by the formula surface area equals 2 pi r squared plus 2 pi r times h, where r is the radius of the cylinder and h is the height. Note those are two dimensions that were given to us as binomials. So we will substitute x plus 1 and x plus 4 for their respective variables in this equation, multiply binomials, x plus 1 times itself and x plus 1 times x plus 4, multiplying carefully, use the FOIL method, first, outer, inner, and last, combine like terms, and simplify. And then notice we can factor out a greatest common factor of 2 pi. Now there's a 2 pi in both terms, so that can be factored out. Remember from the last section's factoring is the same as undistributing. We just call it factoring. Combine like terms once again to rewrite the equation in standard form, or I'm sorry, the expression in this case, in standard form, and find that the correct answer is choice C. So again, just a good application of using these skills of multiplying binomials in order to solve a real-life type problem, since cylinders exist. And here's your opportunity to show that you have got it. What is the total surface area of a cylinder with radius x plus 2 and height x plus 4? Write your answer as a polynomial in standard form. Please make your selection from the choices below. And for example, problem number 5. You can use the FOIL method when you multiply two binomials, but it's not helpful when multiplying a trinomial and a binomial. In this case, you can use a vertical method to distribute each term. And I'd like to give a side note quickly about this comment at the top. I had a college professor, a math professor, who said that FOIL was the worst thing that a high school teacher could teach their math students. While I'm not sure I agree with that, he said the problem is that when students learn FOIL and they depend so heavily on FOIL, they're unsure what to do when they're faced with multiplying polynomials that are greater than binomials, just like this is talking about. When all of a sudden you find yourself with 3 terms, which one's the outer, inner, last? It all gets a little confusing and some terms may be left out. So anyhow, here's one option, and we'll discuss others, but here's one option for multiplying a trinomial and a binomial. The question is, what is a simpler form of 3x squared plus x minus 5 times 2x minus 7? Multiply by arranging the polynomials vertically as shown. And note that we've lined up like terms. The 3x squared has no like term in the binomial. X and its like term 2x are aligned vertically, And -5 and the other constant, the like term of -5, -7, are also lined up vertically. And then multiply. First by -7 in the very traditional way of multiplication, and then multiply by 2x, all the while keeping like terms aligned vertically. Add like terms vertically. Combine like terms and simplify if necessary. In this problem, it looks as though it's not necessary. And find that the product is 6x cubed minus 19x squared minus 17x plus 35. And your chance to show that you have got it. Number A, letter A. What is a simpler form of 2x squared minus 3x plus 1 times x minus 3? And how can you use the distributive property to find the product of a trinomial and a binomial? Your answer should be written in complete sentences to describe the process of using the distributive property to find the product of a trinomial and a binomial. And at the end of the videos, I will likely be providing for you the lesson check problems, the ones that you are assigned after completing the videos. You may do with these as you like. You can ignore the fact that they are here. You may pause the video and complete work from the lesson check problems on separate paper. You may pause the video and screenshot it so that you can save your screenshots for work offline or for printing and working on paper if you prefer to do your work on paper. Here are problems 1 and 2. I'll advance to the next set of problems. Problems 3 and 4. Now's your opportunity to pause. And finally, problems 5, 6, and 7 of your assigned lesson check for this section. Thank you.